All right, so today we're going to talk about chemical equations. So a chemical equation is what they call a shorthand. So it's a shorthand used by chemists. So it tells you what's happening in a chemical equation. So there are two parts of a chemical equation. There are reactants and there are products. So we say that, and this right here, the arrow is called the yield. So we can say that reactants yield products. All right. So when you write a chemical equation, reactants always go to the left, and products always go to the right of the yield. All right. So there's a couple of parts of chemical equations you need to be familiar with. So we have reactants and products. We have yields. If you have something like this, that's a reversible reaction. So you can write it with two arrows. In college, we kind of wrote it with two half arrows. So either way is fine. Okay, so if there's, and we'll talk about reversible reactions later, there are coefficients and subscripts. So if I took this, let me try to figure out the equation to give you. So if I have iron and oxygen, and that yields iron 2 oxide, or iron 3 oxide. There are different things here. So if we look at this reaction, I have my reactants and my products. Right now, I don't have the same amount of reactants and products. I have one iron atom here, and I have two there. All right, so to fix this, I would have to add a coefficient. I have two irons and two irons, and I have two oxygens and three oxygens. So now I have to go and correct this. So I added two there. So now I have 6 oxygens, and I have 6 oxygens, but now I have 4. So I have to come correct this, and then go 4. So now, chemical equation. So a couple things. So these numbers right here are coefficients. And coefficients, these multiply. They multiply the entire compound. We talked about subscripts the other day. The subscript 2, this subscript 2 here, right, only multiplies the oxygen, right? But this coefficient 3 multiplies everything. So I have 4 irons here. I have 3 times 2, I have 6 oxygens here. But this 2 here multiplies both the iron. So I have 2 times 2, I have 4 irons, and 2 times 3, I have 6 oxygens. So know the difference between a coefficient and subscript. I can also have what they call phase descriptions, right? So phase description. So if I was going to put a phase description here, iron comes as a solid. Let me erase this right here. I'll fix it. O2 comes as a gas, and iron 3 oxide is a solid again. So I could put phase descriptions on there, and those become important when you do what are called net ionic equations, but we're not going to do those in summer school. Okay, so we'll move on. All right, so chemical equations. Let me resize this a little bit. All right, so they must follow what are called the laws of conservation. All right, so they must follow the laws of conservation. And you remember those laws all the way from elementary school, probably. You know, matter is not created or destroyed, only transferred from one substance to another. So those are the laws. So conservation of mass. So if you remember our periodic table, we talked about molar mass. So coefficients can indicate moles, and so can subscripts. So if I look at hydrogen here, right, I have 2 times 2, I have 4 moles of hydrogen. So roughly around 4 grams. I have 2 moles of oxygen, so roughly around 32 grams. And I have 2 moles of water, and each water is 18, right? So I have 36 grams of product. So if you look at, I have the same amount of mass in the reactants, I do the products. So the law of conservation of mass is met. All right. I lost my pen for a minute. All right, so matter is just counting atoms. Again, I have 4 atoms here, right? I have 4 atoms here. I have 2 atoms here, and I have 2 atoms there. So mass and matter. And energy we'll talk about later on in the summer semester when we talk about thermochemistry. But that has to be true as well. Okay, so balancing is pretty easy, right? So the important thing with balancing is we can only change coefficients. So there are a couple types of chemical equations. This is called a skeleton equation here. And the skeleton equation is balanced for charge only, right? So you haven't talked about charges in your first semester yet, but if you did, you would know that silver ion has a 1 positive charge and nitrate has a 1 negative charge. So you could say that these two are balanced, right? Each hydrogen has a positive charge and each sulfide has a 2 negative charge. So 2 positives and 2 negatives would mean it's balanced, right? So those are balanced for charges, but not for matter, right? So we need to follow the laws of conservation of mass and matter. So we will learn how to balance. Okay, so I can only change coefficients. I can't change subscripts from the skeleton. So the easy way to do this is start looking at your atoms. I always say to leave oxygen for last because it usually balances itself at the end. So we'll go 1 atom at a time. We'll look at the first atoms. So in here we have silver as our first atom. I have 1 silver here and I have 2 over there. So I'll start by putting a 2 here. Right, so now I have 2 silver atoms here and I have 2 silver atoms there. Right, nitrate is a polyatomic ion. Right, so it comes together. I have 2 nitrates here and I have 1 nitrate over here. So I can try to fix that by putting a 2 here. Right, so now I have 2 hydrogens here. I now have 2 hydrogens there. I have 1 sulfur here. I have 1 sulfur there. Bitchin. So balancing is bitchin. So I always say bitchin when I'm done. This is done. Right. So now it follows the laws of conservation of mass and matter. If we look at the next one below. Alright, so if we look at the next equation, we have zinc. So we'll go 1 at a time again. This was a little different. So I have zinc, and I have 3 zincs over here. So I can start by adding 3 there. Now you'll notice that I have a hydroxide here, but I don't have any hydroxides on the other side. Right, so I want to save that hydroxide for later because sometimes things work themselves out. I have 3 hydrogens here, but you notice I have hydrogens with that hydroxide here as well. So again, let's look for things that we can fix quickly. I have phosphate here and I have phosphate here, so I can fix that. Now I have 2 phosphates here and I have 1 phosphate here, so I can try to fix with the 2 here. Right. So now let's work on fixing the hydrogens and the oxygens. Right. So let's see how many hydrogens I have. I have 3 times 2. I have 6 hydrogens here. I have 2 times 3. I have 6 hydrogens here. So together that's 12. So I can try to make hold on a second, I've lost my, there we go. Alright, so I can make this a 6 here, so I have 12. So let's go ahead and count now. Let's count my oxygens. So now I have, let's erase these. We're going to count oxygens now. So over here I have 6 oxygens here. I have 2 times 4, I have 8 oxygens here. I have 2 times 4, I have 8 oxygens here, and I have 6 oxygens here. So now all of my atoms match up. All right, so that's how you do it. That's kind of the easy way, but you just work it back and forth. Now when you come to take a quiz on a balancing and it's asking you for coefficients, don't choose the answer until you can make both sides equal. All right. Now here's a word equation. So this is a word equation. So I need to make a word equation into a skeleton. All right. So in your homework, I've given you what the skeleton should look like. You just have to assemble it below because you haven't been through that in your first semester yet. So we have hydrogen here. Now hydrogen, H2. This plus sign, sometimes I use the word and. So hydrogen and sulfur yield hydrogen sulfide. Okay, remember your diatomics. Most gases are diatomic. So I have that. So if you look at this now, I have hydrogen and sulfur, hydrogen sulfide. I have 2 here, 2, 1 and 1. All you have to do is write it. Right. To the next one, we have iron 3 chloride. Plus calcium hydroxide. Yields. Remember that word yield means arrow. Iron 3 hydroxide. Plus calcium chloride. Alright, so let's do our balancing thing again. I have 1 iron here, I have 1 there. Looks pretty good. I have 3 chlorides here and 2 there. Right? So I've got to make them equal. So I can say 2 times 3 is 6, and 3 times 2 is 6. Right, now I have 1 calcium here and 3 here. Right, so I'm going to have to put 3 there. Now I have 3 hydroxides. I have 3 hydroxides. Oh, there's a problem here because I made a problem. Calcium hydroxide should have a 2 here. So I have 6 there. Right, so this is going to have to be a 2. So I have 2 irons, 6 hydroxides, and 6 hydroxides. Right, so that's it is. And this just here gives the answers to what we did. All right, okay. There's going to be one more screencast before you can do your homework. And I'll post that as soon as I get done. Bye.